So what we have here is we have a polymer system, a plastic that was developed for applications involving composites for air and spacecraft. However, this type of system has found utility as a wire coating to enable a whole new class of pacemaker leads. So, as you see here, we have a new type of pacemaker lead that's actually a lot thinner than the current pacemaker leads out there. And it's also designed so that there are several leads that fit into the heart ventricle, so that if one of the leads starts to fail, the pacemaker device can just simply switch to a different lead. So this avoids revision surgery. The idea here, or why this is important, is that this, the size of the wires and the ability to switch leads not only prevents revision surgery, but it gives people a longer lifespan. So every time one of these pacemakers is used, a life is saved. And we are approaching now 750,000 lives where this type of pacemaker system has been implanted.
Hi, I'm Ken Dudley with NASA Langley Research Center in the Electromagnetics and Sensors branch, and I'm here today to talk to you about the SANS-EC sensor, which is an electromagnetic sensor that is designed to measure just about anything. It's a resonance sensor that is in the form of a shape of a spiral made out of a conductive material that when energized by an external electromagnetic field, it will resonate, it will self-resonate. You can kind of think of it as a bell. The way that a bell is rung by an external mechanical force, like a little hammer striking it, and it rings at a certain frequency. And that frequency is determined by the size and the shape and the materials that the bell is made out of. A SANS-EC is very similar, except for it's an electromagnetic wave that is the hammer that strikes the sensor. And when it resonates at a self-resonating frequency, such that if that sensor comes into contact with a material or a structure or something that you are intending to sense, say like a human body or a composite component of an aircraft, it will couple its energy into that system and it will shift its resonant frequency according to the material properties that material system is made of. That's a very remarkable thing for SANS-EC sensors, for any type of sensor, in that it uses the intrinsic properties of the material to help determine the material system state. We have licensed the technology to a company by the name of Textile Instruments that has hopes of embedding these sensors in a fabric-based sense. It turns out you can make these sensors out of conductive threads, but in embedding these sensors into normal clothing, particularly things like sportswear, hospital gowns, active wear for all ages.